I do that.
That works too. Okay?
When you look at it, you're like,
Anything else?
Number 15, the last line.
Okay, let's look at number 15. We have this triangle.
Would you do when you find the parallel lines again?
When I find the parallel, what you talking about?
They have like one parallel line and then one long side. It says find the.
Okay, I'm coming. That's when you look at the sides of the triangle. It's like sides of triangle instead of pieces. All right, we have AR. Okay. In number 15, we were told that AR had a measure of 12. AT had a measure of 20, which means this is 8. AP was 30. RN was 15. Okay? And we were asked to find the missing pieces. All right, well, we learned in our theorem from Friday that in a triangle, if this line is parallel to the bottom line, then the two segments on the sides have been separated proportionally, right? Excuse me. Let's start by looking for AN and NP, okay? We'll call it X and Y. If I'm going to set up a proportion, I've got to have the same thing in the numerators and the denominator. Remember, this whole thing was 20. If I'm looking for X, and I can't say X over Y because that's too many unknowns. On this side, I have X and I know 30, correct? So if I say X over 30 is equal to something from the other side, what does it have to be? 12 over 20. Because the top portion over the whole thing is equal to the top portion over the whole thing. So my proportion is 12 over 20 equals X over 30. All right, now you can cross multiply and divide. You can simplify that fraction before you start if you want to. Either way, what do you get as an answer? 18? Yes, AN is equal to 18. All right, well, do you have to set up a proportion to find NP? In this case, no, because if the whole thing's 30 and AN is 18, then NP is 12. All right? Now, what have we created by putting this line here? Two similar triangles. And what do we know about similar triangles? Corresponding sides are proportional. So now we have to, when we're looking for this, what's corresponding to Z? 15. Okay? Now I have to look at this as this is the bottom of an entire triangle. This is the bottom of an entire triangle. I'm no longer talking about pieces of a whole triangle. I'm talking about two completely separate ones. So if I wanted to set up the proportion, I'm going to take either side, but I'm going to use the entire side of the smaller triangle over the entire bottom of the smaller triangle is equal to the entire side of the larger triangle over the entire bottom of the larger triangle. And if I'm taking numbers from the left-hand side, I have to take them all from the left. Okay? I can't take 12 and then 30 because those aren't exactly the same on both sides. And then I find the value of Z. Because now you're talking about, see here we were just talking about little pieces of the big triangle. Now we've got two completely separate triangles. She get 25. Okay, TP had a value of 25.
But can 20 and 15 be switched, or is that
Yes, they can be,
They can be.
because it's still 15 times 20.
Would that
Because that way you're doing the entire bottom over the entire bottom equals the entire side over the entire side.
Would that work on any problem, or just okay?
As long as you've got the same triangle in the same spot.
Okay.
Okay? You just have to make sure you're consistent. Alright, turn to the chapter test. On page 279. Number 1 says 2 sides of a rectangle have lengths of 20 and 32. Okay, well that's fine. Find in simplest form the the ratio of the shorter side to the longer side. So what number goes first? The shorter, 20. Longer goes second. Now, in simplest form, how do we do this? We look for a number that goes into 20 and 32. What goes into 20 and 32? Is there a bigger number? 4. Okay, so the first part is 5/8. This is making sure you're getting your stuff in the right order. The second question says, find the ratio of the perimeter to the longer side. All right, we had a rectangle that was 20 by 32. How do you find the perimeter?
Each by 2.5.
Right, because it's all the sides added up together, right? So it's 40 plus 64, which is 104. Perimeter to the longer side, 32. Okay, so whatever they're asking for, you're just simply setting them up. And then you've got to reduce this. What can go into, let's just start reducing. 8. Okay. Huh? No.
13
Okay.
is
All right, number 2 said this, and there is no picture. It says if quadrilateral ABCD is similar to quadrilateral THUS, then angle U is congruent to what angle? Angle C. And BC over HU is equal to AD over what? TS. Understanding that when you say similar parts, the letters and the order of the letters is very, very important. They tell you what the corresponding parts are. Number 3 says if X to Y to Z is equal to 4, 6 to 9, and Z has a value of 45. What are the values of X and Y? How would you figure that out? You'd multiply them by 5, because how did you turn, if this first one represents, 4 represents X, 6 represents Y, 9 represents Z. If we've made Z 45, that means we had to increase this by a multiple of 5, right? In order to keep it in the same ratio, we have to do the same thing to the others. So, X, therefore, would equal 20, and Y would equal 30.